All right, so we have these. There's example one, and there's actually about five of them, five portions of example one. And so we're going to just talk about the rules and then go from there and just work them out. This is going to be very simple, very easy. All right, if you look at the first one here, we have an exponent. So that means this is, and there's no number in front right here, the number in front. So this is the power rule. So the power rule says all we do is take the exponent, move it in front, and subtract 1 from the exponent. So we're going to do f prime, since we're talking about the derivative, f prime of x equals 6. We took it down in front. And we do x and do 6 minus 1, which is 5. So again, remember we take the exponent, move it in front, and then we subtract 1 from that exponent. So move the 6 in front, subtract 1 from 6, and then it's that. All right, now the next one deals with the pretty much everything. We have the sum and we have the difference rule right here. We have the sum rule here. Difference rule. This is the sum rule. We have the power rule right here. Power. And then we have a constant rule. Power the multiple constant rule. Constant multiple rule. And then also we have the constant rule right here. Because we're going to deal with each one of those rules all together. So first off, we said again for each one of these, since it's a sum and difference, all we do is take derivative of each piece, and then we do either subtraction or addition depending on the actual function that's there. So for the first part, we have the power rule. So just like we did for this first one up here, we're going to go ahead and actually take the exponent down and subtract 1 from it. So that'll be 2. And then 2 minus 1 is understood to be 1. So that's our power rule. All right, then we have the subtraction. All right, and this next one we have a constant multiple rule. And there's an understood 1 right there. So just pulling it off to the side really quickly, we have 4x to the first power. If we do the constant multiple rule, that means we leave the 4 alone. We take the exponent and move it in front. So we do times 1. And then here we have 1 minus 1. 1 minus 1 is 0, right? So anything to the 0 power is just considered 1, right? Right. So that means that's 4 times 1, which is just 4. Right? Okay. All right, so we have 4 there. And then we said the derivative of a constant is always a 0. So derivative of a constant, 2 is a constant, so that means that's going to be 0 back there. And so here, I'm going to simplify it down, so we have the final answer, 2x minus 4. So again, we take the exponent and move it in front. Here, we take this portion, move it in front, move the 1 in front there, so 4 times 1, and x to the 1 minus 1. And then all that simplifies down to 4. And then the derivative constant is 0. Okay, not bad. Okay, then when it comes to C, we're going to do the same thing again, but we have all these different rules. So we know we have the constant multiple rule here, the constant multiple rule there, constant multiple rule there, and actually right there too. So we have it all the way through. And then we have our difference rule right here. We have difference, and then we have addition, sum there. So we're going to do this. So again, remember, you keep the constant in front and you bring the exponent down. So when we do our derivative here, we'll keep the 2. Remember, bring the 4 down. And then we subtract 1 from the exponent. And then we have the 7. We bring the 3 down and subtract 1 to give us x squared. Then there's plus 12. Bring that 2 down. Subtract 1 from it gives you 1 to the first power, sorry. And then here we have 8 times 1. And again, we have, just like we had in the last problem, we had to the first power right here. And when we did that, the answer just came back as just x to the 0, which is just 1. And then the constant in the back is 0. All right, so for each one of these, we dealt with that portion, dealt with that portion, dealt with that one, and individually. And now we just simplify it down. Let me move it over some, sorry. I have space there. It's 8x cubed minus 21x squared plus 24x minus 8. And again, each time you take the exponent, move it down, multiply it, subtract 1 from it. And each time here you subtract 1. So if you remember things about degrees, when it comes to your derivative, it's always 1 degree less. So this had a degree of 4 because your highest exponent was 4. Now this has a degree of 3 because your highest exponent is 3. So if you remember that part, great. If not, then we'll talk about that later. We'll see it later. Okay. Now, when it comes to D, we haven't talked about multiplication because we know that's x cubed times x squared plus 5. So we haven't talked about multiplication before. So what we're going to do is go ahead and distribute this x cubed to both terms. And then we're going to do like we did up top. So here we're going to do x. Whenever you multiply numbers, or multiply exponent, whenever you're multiplying terms with the same base, you add the exponents. So that means this will be 5. This will be 5x cubed. All right, so then when we do our derivative, again, we'll bring the exponent down. So that's 5x squared. And then we'll bring the 3 down and do 5 times 3, which is 15, x squared. Sorry, that should be 4th right here. Sorry, my fault. Should be a 4 right there. Everything's all jumbled up now. Sorry, guys. This is our answer here. Again, that's 5x to the 4th plus 15x squared. This was the answer for C. Everything's all jumbled up. I'm sorry, guys. It's not supposed to be this jumbled up. I had enough space. All right, and then the last one here. Again, we haven't talked about anything like a binomial being squared when it comes to like our rules. So again, we don't know how to do that part. So again, we're going to multiply this out. So we know squared means that we have 2 of the same values that's inside that parenthesis. 2 quantities, 2 of the same quantities. So we're multiplying those. And so we're going to FOIL it or do box method, whichever one you did in your previous classes. It's up to you, whoever your teacher taught you, let you know. So here we know we're going to have x to the 4th. Remember, you add exponents when you multiply. Okay, and then we have 4x squared, which is 8x squared plus 16. All right, now at this point, we just go ahead and take our derivative of it, which means we're going to take the exponent, move it down. Oh, come on. There we go. Perfect. So that gets us 4x cubed plus 16x plus 0. So we'll leave the 0 off. And that's it. So finding the derivative is really not bad. All you have to do is remember is to take the exponent, move it down, and subtract 1 from the exponent. If there's a constant there, just multiply those 2 pieces together and you get an answer. So it's really not bad. It's really not bad. All right, so then let's go ahead and move on to antiderivatives.